Have you ever struggled with ensuring that your data models are validated correctly in your applications? It can be a real headache, especially when you're working with TypeScript. If that's you, then you're in the right place. Today, we're diving into how to implement object validation using TypeScript. I totally get it. You've defined your data models using TypeScript interfaces, but those interfaces only work at compile time. This means that when your application is running, you still need to validate the data coming in, especially from HTTP requests. You're not alone in this struggle. Many developers face the same challenge. Here's the specific question we're addressing today. One user asked, how can I implement runtime object validation in my Express API and React Client app using TypeScript? This is a common scenario, and it's crucial for ensuring that your application behaves as expected. So what's the issue here? TypeScript interfaces are great for type safety during development, but they don't help you at runtime. This means that if you receive malformed data, your application could crash or behave unexpectedly. We need a solution that bridges this gap. And stick around. I have a fantastic solution that will not only help you validate your data, but also improve your overall application reliability. You won't want to miss it. To implement runtime object validation in TypeScript, the user should start by installing a validation library. One popular choice is Joy, which allows for schema-based validation. Next, the user should define a validation schema that matches their TypeScript interface. This schema will be used to validate incoming data. Now the user can implement the validation in their Express route. They should validate the incoming request body against the defined schema. Finally, the user should test the validation by sending various requests to their API. This will help ensure that the validation works as expected. Fun fact, did you know that the first version of TypeScript was released in 2012? It has come a long way since then, and now it's a staple in modern web development. Now, let's look at the answers provided by other users. One alternative solution for runtime object validation in TypeScript is a lightweight library called Smokescreen. This library utilizes TypeScript features to validate objects during JavaScript runtime. Although JavaScript lacks type information at runtime, Smokescreen uses TypeScript decorators to achieve this. With Smokescreen, you can serialize a person object into JSON and deserialize JSON back into a person object. It also performs type validation, ensuring that properties like age are of the correct type, and it can handle custom validators and null checks. Let's take a look at another answer from another user. An alternative solution for object validation in TypeScript is provided by a user who recommends a library called CheckEasy. This library is designed to be TypeScript-friendly, lightweight, and easily extensible with custom validators. To implement validation, you can define a validator using CheckEasy's functions. For example, you can create a validator for an object with various types and constraints, such as integers, strings, and optional fields. The library also provides clear error messages when validation fails, making it easier to debug issues with the data structure. That's it for that response. Let's explore another one. An alternative approach for object validation in TypeScript is to use a library called ts.validator.fluent. This framework allows for generic object validation with fluent rules. To validate a TypeScript model, you define validation rules. For instance, you can create a person class and specify that the name property cannot be empty. Then you can validate the model synchronously or asynchronously. Let's move forward and look at another answer. An alternative approach for object validation in TypeScript is to use a library called tsJSON-object. This user created a validator using decorators to define required and optional fields, along with custom validations. For example, when creating a new person object, if the name is missing or not a string, it will throw a type error. This ensures that your data conforms to the defined structure at runtime. Let's take a look at another answer from another user. An alternative approach to object validation in TypeScript is provided by a user who created a library called computed types. This library aims to be simple to use, reusable, and share the same interfaces as TypeScript. With computed types, you can define a schema for your data models. For example, a user schema can be created to validate properties like name, amount, and flags. This is similar to how you would do it with Joy, but it integrates directly with TypeScript types. For comparison, the equivalent code using Joy would look like this, where you define the schema and types separately. The computed types library streamlines this process. For more details and examples, you can visit the Computed Types GitHub page. Here's a pro tip: always validate your data at both compile time and runtime. This dual approach will save you from many headaches down the line. And there you have it. You now know how to implement runtime object validation in your TypeScript applications. Remember, validating your data is crucial for building reliable applications. If you found this video helpful, please hit the subscribe button for more tips. And don't forget to check out our next video on advanced TypeScript features.